A'udhu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. Dear student, Assalamu alaikum. Today we are going to start unit number 6. The name of unit number 6 is work and energy. And this today we will do the topic of today's lecture are 6.1 and 6.2. Yes, yes. Do you have any question? Okay. Topic of today's lectures are 6.1 and 6.2. 6.1 is work and 6.2 is energy. These are on page number uh, please mute your mic, Alicia. Okay. Pages covered 119, 120 and 121. We will cover these pages today. And topics are 6.1 and 6.2. 6.1 is work and 6.2 is energy. So we are going to start chapter number 6, work and energy. So if you, unit number 6, work and energy. This is the chapter we are going to start. So I am going to start 6.1, which is work. So first of all, I give you the brief description about work before starting the work. Generally, work refers to performing some task or job. In science, work has precise meaning. For example, a man carrying a load is doing work, but he is not doing work if he is not moving while keeping the load on his head. Scientifically, work is done only when energy is used. Thus, work and energy are related to each other. The concept of energy is an important concept in physics. It helps us to identify the changes that occurs when work is done. This unit deals with the concepts of work, power, and energy. So, if someone if someone is reading a book, or if someone is writing something, we say he is doing work. But according to the precise definition, according to the science rules, he is not doing work, because he is although he is sitting and reading or writing the book, but he is not moving. So in science and especially in physics, work is said to be done when a force is applied and the body covers some displacement in the direction of force. Then we say he is doing work. Otherwise, if a laborer is carrying a load on his head and he is not moving, so it means he's not doing work. But if he moves and carry these bricks on his head on the top floor, so we will say he's moving. Since he is moving, that's why we say he is doing work. So in physics, you should know when the force is applied and the body covers displacement in the direction of force, then we say he is doing work. But if he is carrying the load on his head and he is not moving, so he is not doing work according to the physics definition. So I'm going to start 6.1, work. In physics, work is said to be done when a force acts on a body and moves it in the direction of the force. Suppose this is a block and we apply the force on the block. After some time, the force will move the body and it covers some displacement in the direction of force. This is the first position of the block. Then if we apply the force and this block moves to this position now, the second position now, so it has covered the displacement, then we say he is doing the work is said to be done. Okay. The question arises, how much work is done? Naturally, greater is the force acting on the body, and the longer the displacement distance moved, it larger would be the work done. It means if we apply the greater force on the block, it will move faster, or it will cover long displacement. It will cover more distance in the direction of force. Then we will say the greater will be the work done. Mathematically, how we can write the work definition? So work done is the product of force and the displacement. Say if we denote the work done with W and force with F or displacement with S, so it's mean work is said to be done. This is the block. This is the first position of the block. When I apply the force on the block, it moves in the direction of force. First, it was the initial position of the block. Then, after applying the force, it moves to the other position or other position. So it means work has to be done. So how we define the work? Work, if we say the work done is denoted with capital W, and force is denoted with capital F, and displacement is denoted with S. So work done will be Fs. F is the force, S is the displacement. So work done is displacement of body in the direction of force. When I apply the force, the body will move in the direction of the force. Now, sometimes, so you should remember this. W is equal to Fs is the formula for the work done. W is equal to Fs. Fs is the formula for the work done. So you should remember this by heart. Sometimes, what happened? Uh, Sometimes force and displacement do not have the same direction, such as in shown figure 6.2. This is another case. Here, the force F is making an angle with theta with the displacement. Suppose you have a small car, a small toy car. What happened with the help of the thread, you push the car. So force and displacement are not in the same direction. So force is uh, making some angle with the earth. So it means so for whenever the force is making an angle with the earth, it has two components. As we have discussed in our earlier chapter, whenever force is making an angle with the earth, so force F, so the flow force will be broken into two components. One is called Fx component, which is called the horizontal component of the force, and Fy is the vertical component of the force. So this is the second condition. Sometimes it happens force and displacement are do not have the same direction as shown in the figure. If you look at the figure 6.2, work done by a force inclined with the displacement. So what force is making an angle. Suppose you don't consider this block, you can consider a small toy car over here. What happened when you push the car? When you pull the car, it is this force is applying, and the body is moving in the x direction, or the car or toy car is moving in the on the land, on the earth. So it is making this force is making some angle with the earth. So whenever the force is making some angle with the earth, it has two components. One is Fx component. Fx means horizontal component of the force, and Fy is the vertical component of the force. So resolving F into perpendicular component Fx and Fy as shown in figure. So Fx, as we have already discussed in the earlier chapter, Fx is equal to F cos theta, and Fy is equal to F sine of theta. Fx is the horizontal component of force, and if you recall this perpendicular, when we studied perpendicular component of the force, when the force is making some angle with the land or the earth, so it is split down into two components. One is called the horizontal component of the force, and the other one is called the vertical component of the force. Horizontal component of the force is denoted with Fx, and the vertical component of the force is denoted with Fy. So if we use the same formula as we discussed earlier chapters, Fx is equal to F cosine theta, or simply F cos theta, or Fy is equal to F sine of theta, or we say F sine theta. When force and displacement are parallel, then only the x component Fx parallel to the displacement causes the body to move on the surface, and not the y component. What does this mean? Suppose you are pulling the car with the thread. So the X component is responsible the body which is acting on the since our toy car is moving on the earth, it is moving on the land. So it's mean X component, only X component is working. There Fy component is not working. So we will consider only Fx component because our motion, the motion of the toy car is only on the earth, and only Fx component, horizontal component of force is acting. So we will neglect y component of the force, which is Fy is equal to F sin of theta. Only Fx is equal to F cos theta is responsible for the body to move on the land. So you know the formula W is equal to, as we discussed uh, uh, here, the formula for the work done is equal to Fs. So if we put F is equal to Fx, because only the X component of the force is responsible for the toy car to move, or the block on or the block in the direction of the force. So we will take only X component of the force. So we will replace F with Fx. So you know Fx is equal to F cos theta. Just put Fx is equal to F cos theta in this formula. So you will get F cos theta times S. So in the next you can write Fs cos theta. So because only the X component of the force is responsible for the body to move on the land. So work is done when a force acting on a body displaces it in the direction of force. So you guys, you need to memorize this definition, this pink color definition. Uh, if they ask you what is defined work, then you will have to answer this. Work is done when a force acting on a body displaces it in the direction of force. Displaces mean the first position of the body is this, and then when the force is applied, it will move in the other position. So it has displaces the body from this position to this body. So work is done when a force acting on a body displaces it in the direction of a force. So work is a scalar quantity. So there are the two quantities. One is scalar quantity, and one is a vector quantity. Scalar quantities are those quantities which require only magnitude for their description. So scalar quantities, example of scalar quantities are mass, time. These are the example of the scalar quantity. Similarly, work done is also a scalar quantity because it requires only magnitude. It depends on the force acting on a body, displacement of the body, and the angle between them. This is the angle. This is the angle theta between them. So it is depending upon on what factors. It is depending upon the force acting on the body, displacement of the body, how much displacement it covers from this point to this point. So it is depending how much force is applied, how much displacement is covered from this point to this point, and it is also depending upon the angle between the theta between the angle between them. Okay, so remember, guys, you need to memorize this formula. The definition of the work is done when a force acting on a body displaces it in the direction of the force. So you should remember this. Work is a scalar quantity. It is depending upon the force, displacement, and the angle between them. Okay. So now we discuss the unit of the force. SI unit of the work is SI unit of a work is joule. So it is defined as, how we define the joule now. So you should know SI unit of the work is joule. So now I am going to define unit of joule. Unit of work, joule. The amount of work is 1 joule when a force of 1 Newton displaces a body through 1 meter in the direction of force. Suppose I'm going to define unit of work, which is joule. So work is said to be 1 joule if when a force of 1 Newton, if we take the force of 1 Newton and it displaces the body from this position to this position 1 meter in the direction of the force, then I will say the work is done be work is said to be done of 1 joule. So we have done the 1 joule work. Again, unit of work, SI unit of work is joule. It is defined as the amount of work is 1 joule when a force of 1 Newton displaces the body to 1 meter in the direction of the force. Suppose I will say I apply the force F. F is 1 Newton on this body, and it displaces the body in this direction, if the distance is 1 meter, then the in the direction of the force, then the work is said to be 1 joule. So similarly, so how we say we can write this definition here: 1 joule is equal to 1 Newton and 1 meter. If work is said to be 1 joule, if we apply the force of 1 Newton and the body covers 1 meter displacement in the direction of force, then our work will be 1 joule. Joule is the smallest unit of work. The bigger units of the works. What are the bigger unit of the work? 1 kilojoule, kj. 1 kilojoule is noted with kj, and it is 1000 joule. You know, k means 10 to the power 3, and it is 1000 joule. 1 megajoule is a bigger unit. Mj, capital Mj. So how many zeros? 6 zeros. So 10 to the power, it can be written as 10 to the power 6 joule. So you came to know that joule is the smallest unit. So bigger units of the work done are kilojoules and megajoules. So kilojoule is denoted with kj, and the megajoule is denoted with mj. So if we say kj is 1000 joule, so we can write 1, 2, 3. How many zeros are 1, 2, 3, 10 power 3 joule? So 1 megajoule, m capital mj. It's mean how many zeros? 10 power 6 joule. So you should remember, students, you should remember that joule is the smallest unit, while other unit, bigger unit of work is kilojoules and megajoules. And kilojoule is 10 power 3 joule, and megajoule is mj and 10 power 6 joule. Next, we discuss the example now, 6.1, which is on page number 121. If you open 9th class textbook, page number 121, you will find this example. Example 6.1. I read the example first. A girl carries a 10 kilogram bag upstairs to a height of 18 steps, each 20 centimeter high. Calculate the amount of work as she done to carry the bag. We will use the same formula. Work done is equal to Fs, or here height is involved, so S will be replaced with H. So whenever the distance is on the land, on the earth, then S will come. But if we are moving up, so the S will be replaced with H. So our formula W is equal to Fs will be replaced with Fh. I read, a girl carries a 10 kilogram bag upstairs to a height of 18 steps. So there are the 18 steps of the upstairs of the stairs. Each is the height of one step to the another step is 20 centimeter height. So calculate the amount of work she has done to carry the bag. So I'm going to write the given data. Mass of a bag is 10 kilogram. Look, mass of the bag is 10 kilogram. We need to find out the weight. Weight of the bag. How will you find the weight? Weight formula for weight is W is equal to mg. So m is 10, and you know the value of g is 10. So 10 multiplied by 10 will be 100 Newton, and the unit of weight is Newton. Again, mass of bag is given to me 10 kilogram. I don't need to convert this into, this is already in SI unit. So unit of mass is kilogram. So this is 10 kilogram. And the weight, we need to convert this into weight by using the formula. Weight of the bag is W is equal to mg. You know this formula, W is equal to mg. So how will I convert this? 10, mass is 10 and value of g is 10. If you multiply 10 by 10, you will get 100 Newton. Okay, so first of all, I will find the height. How we need to convert this 20 centimeter into meter by dividing this with 100. So if you divide 20 by 100, you will get 0.2 meter. You will get to 0.2 meter. How will you convert 20 divided by 100? You will get 0.2. And you know this is the height of one step to another step. The height of one step to another step is 0.2. So how many steps we have? We have 18 steps, multiply with this. So we will get total height. So total height of all the stairs, 18 steps will be 3.6 meters. So we have found height. So I will use the formula since we want to find out the work done. So formula for work done is Fs. But I told you since height is involved, so S will be replaced with H. So W is equal to Fh. So I'm just going to put this. Force is 100. So I'm putting 100 and H is 3.6. If you multiply 100 with 3.6, you will get 360 joule. So the girl has done 360 joule of work. So again, mass of the bag is given to me 10 kilogram. So I converted this into weight. How I convert this into weight? By using the formula W is equal to mg. Just m is 10 and weight is g is 10. So if you multiply 10 with 10, you will get 100 Newton. So then I converted height. How many steps are 18? I convert this into meter first. 20 divided by 100, it is 0.2 meter. So 0.2 meter multiplied by 18, so you will get the total height. So 3.6. So since work done formula is Fs, but I am replacing S with H, because we are moving upstairs. So here we are moving upstairs. That's why I am using 18 steps. So total height, in order to calculate the total height, I will multiply 18 with 0.2, which is 3.6 meter. So I will use the formula W is equal to FH. So F is 100, F is given to me 100, F is equal to W is equal to, this is 100 Newton, 100 multiplied by 3.6, you will get 360, and the unit of work is joule, as we have already discussed. Now I am moving towards my topic 6.2, which is energy. The definition of the energy is this one: a body possesses energy if it is capable to do work. So I will explain you with the help of examples what is actually energy is. A body possesses energy if it is capable to do work. This the definition. You need to memorize this by heart. Okay. I explain you this with the help of the examples. The energy is an important and fundamental concept in science. It links almost all the natural phenomena. When we say that a body has energy, we mean that it has ability to do work. So this is the example of energy. Water running down the stream has ability to do work. Look, the water is whenever if you go to the Tarbela Dam or Mangla Dam, so you know how they produce the electricity in Tarbela and Mangla Dam. They give the height to the water, and they throw the white from some certain height. So due to the certain height, the body possesses energy. So it is capable of doing work. So it runs the turbines, and with the help of the turbines, they make the electricity. Similarly, if you go to the top floor of your house and you are carrying the brick in your hand, so what will happen if you throw the brick from the top floor of your house? What will happen? You will hear the noise, and if someone is standing down in your house, he can be injured. So it's mean the brick has ability, the brick has energy, which can broke off someone's head. So it's mean a brick carry the energy. So energy has a different forms. So the energy running of water can be used to run water mills or water turbines, as I have already told you. Energy exists in various forms, such as this mechanical. There are so many forms of the energy: heat energy, light energy, sound energy, electrical energy, chemical energy, nuclear energy. These are all the forms of the energy. So energy exists in various forms, such as mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, and nuclear energy. So you will study all these forms of energy in the next topic, which will come soon. Energy exists in various forms, such as mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, and nuclear energy. These are all the forms of the energy. So you need to memorize this definition, and these are the example. You need to water running down. First of all, you will write the definition. A body possesses energy if it is capable to do work. If they ask you to define energy, then you will write this definition. A body possesses energy if it is capable to do work. Then you will give the examples. Water running down the stream has ability to do work. This is the first example. So it possesses energy. The energy of running water can be used to turn water mills and water turbines. You can turn on the with the using this energy. You can turn on the water turbines and make the electricity. So in our next lecture, we will study um, different forms of energy. Mechanical energy possessed by a body of its two types. We will study two types of mechanical energy. Mechanical energy has two types: kinetic energy and the potential energy. But we will study this into in the next chapter. I repeat all things for you. Today, what uh, we discussed work. So I told you, if someone is sitting on the table and is writing or reading something, we say that he is doing work. But according to the physics definition, this he is not doing work. For a body to be doing work, it must move. So whenever we apply the force and the body moves in the direction of the force, then we will say he or she is doing work. But if he is not moving, then we will say he is not doing work according to the physics. So work done is equal to Fs is the formula for the work done. W is equal to Fs. For suppose I apply the force on this block, and this block moves in the first one position to second position, and it covers some displacement. So he is moving. This block is this moving under the action of the force. That's why I say this is doing work. The work has been done. Next, we studied sometimes it happens then force and displacement are not in the same direction. Suppose you are carrying a toy car with the help of the thread. You apply the force with the help of the thread, and the toy car moves on the land on the earth. So in this case, force is making an angle with the x-axis or with the earth. So it is making some angle with the earth. So the only the toy car is moving on the land. It is not moving vertically. So it has two components. One is called fx component and one is called fy component. Only fx component, horizontal component of the force, is responsible for the body to move on the earth. So I will take only x component over here. So formula for W is equal to Fs. So since Fx is responsible for the body to move on the earth, so it will be Fx is equal to W is equal to Fxs. So F cos theta times, if I put Fx is equal to F cos theta, then F cos theta S. So F, we can write W is equal to Fs. Then we define this is the definition of the work. Work is done when a force acting on a body displaces it in the direction of the force. Then we discuss if work is a scalar quantity. So it is depending upon the force, and it is depending upon the displacement and the angle between them. So then we discussed about unit of work, and the SI unit of the work is joule. And then I defined joule. But I said work is said to be 1 joule if we apply the force of 1 Newton and the body moves in the direction of force 1 meter displacement. Then I will say the 1 joule work has to be done. So the joule is a smaller unit. Then bigger unit of the work is kilojoule, which is noted with kJ, and it can be written as 10 power 3 joule. And 1 megajoule, so I will write 10 power 6 joule, which is mega means 10 power 6, as you have already studied prefixes in first chapter. Now we discussed about example 6.1. In this example, our mass is 10 kilogram and our steps are 18. So we will find the total height by First of all, we will convert this 20 centimeter into by dividing this by 100. Then it has been converted into meter. Then the 0.2, the 20 centimeter is equal to 0.2 meter. So multiply 0.2 multiply by 18, you will get height. And force is given to me 10. We convert this into 8. How will we convert this into 8? By multiply, mass is 10, and the acceleration due to gravity is 10. So 10 multiplied by 10 is 100. So as we have already calculated this height, so we will W is equal to FH. Why I am writing the formula for work done is Fs, but why I am writing H? Because height is involved, because we are moving upstairs. That's why S is replaced with H. So just putting the values, F is 100 So F is 100 and H is 3.6. If you multiply this, you will get 360 joule. Then we discussed about energy. This is the definition of the energy. A body possesses energy if it is capable to do work. So then we took the examples of the what is energy. Water running down from the stream. This is the stream, right? Running down from the stream possess the energy. It has the ability to do work, so it possesses energy. The energy of running water can be this energy can be used to run the turbines, water turbines. There are so many forms of energy. Then we discuss mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, and nuclear energy. So energy can be transformed from one form to another form. So energy can be transferred. We will discuss in because we will discuss this in detail. So I will tell you how the energy converts from one form to another form. Then we discussed mechanical energy has two types. One is kinetic energy and one is the potential energy. So we will discuss in our next lecture 6.3, topic 6.3, which is kinetic energy, and we will discuss about the potential energy and other form of the energy. Thank you very much. I hope you understand this. If you have any questions regarding this, please let me know. Or unmute your mic and ask us. Thank you. And your homework is please practice topic by heart uh, and write once on your Raspberry. So this is your homework. If you have any question regarding this, you can feel free to ask. Thank you. Hello. Anyone has any question? Ibrahim, Hussain, Alim, Alisha, any question?